Hello and welcome to our webinar today. Today we will be discussing Fronius products and solutions. Joining me today is my colleague Cyprian Okolo, is the technical sales advisor for the Western African region. It's based in Lagos, Nigeria, and myself, David Mwangi. I'm the technical sales advisor for the Eastern African region. We have a firm in Nairobi, Kenya. Today, a few topics that we want to discuss. We will give you an introduction to Fronius. We will talk about Fronius inverters history. We will discuss the Fronius Snap Inverter series, Fronius Smart Meter, Ohmpilot Gen24 Plus. Then CPN will take over at Wattpilot, do AC coupling, Tauros, PV-Genset systems. And then at the very end, we will provide you with some further details. So because of the content and the limitations of time today, we will try to give you like really brief details about each of the sections. But for sure, at some later stage for our other webinars, we'll give focused attention to each of the specific major topics that will be covered today. So to get started, let's do a quick introduction to Fronius. So Fronius is an Austrian company based in Central Europe. So we have about 7,000 employees currently. The number of patents are approaching 1,450, and the export ratio of about 87%. We have 37 Fronius subsidiaries in different countries, and an additional slightly more than 60 countries with both sales partners or representatives there. And our turnover as of last year was about 1.2 billion euros. So Fronius is a company that has been stable for generations. So the starting of the company was in 1945. And still to date, the company is a family-owned business. And here in this photo, we can see the founder, Mr. Gunther Fronius, and then the second generation, and then our current CEO, Elizabeth. So still a family-owned business. We do have separate business units. We have perfect welding. We also have solar energy and perfect charging. So the pioneer in terms of where the company started was perfect charging in 1945 and perfect welding 1950. And then the solar energy business unit was started in 1992. So looking at the solar energy business unit, what are the figures there? So we have so far installed about 32 gigawatt inverter power. This is represented by more than 3.5 million inverters working for different systems. The energy generated annually is about 42.0 terawatt hours. And yeah, just like we said, we have more than 60 countries with Fronius sales partners and representatives. So coming to the inverters history, let's look at what the development has looked like over the years. So having founded the solar energy business unit in 1992, the first series of inverters, which is the Fronius Sunrise series, was used in some projects in 1995. And from 1995, the development, as you can see here, up to around 2012, the concept was making more or less like central topology inverters. But from 2012, going on to 2013, we started making the Fronius Snap inverters, starting with the Fronius Galvo. Then we had the Fronius Simo, the Primo, the Echo, and the Simo Hybrid. Then in 2017, the Ohmpilot was introduced. We had the Gen24 Plus in the year 2020. And in the year 2021, we launched the Fronius Tauros and the Wattpilot as well. This year, we introduced some improvements or some enhancements to the Snap Inverter Simo, and this is now being referred to as the Fronius Simo Advanced rest of the world. So some of these early systems that were done in 1992 with the Fronius Sunrise series are still running. So we have one of our very good customers, Mr. Panhober, and this system has been running for many years, of course, without failures, but where service has been required, this has been offered, even with spare parts as required. So with Fronius, you do get a partnership without an expiry date. So let's now look at the Fronius Snap inverters. And the Fronius Snap inverters, we have two major categories. So the first category is what we refer to as the Snap inverter residential. And in this category, we have the Fronius Primo that has the power class 3.0 up to 8.2 kilowatt. And therefore, where you see this M, it means that this inverter has 2 MPPTs or multi-MPPT inverter. The power classes for this category, as you can see, starting from 3.0, 3.7, 4.5, and then all the way up to 8.2. It's a transformerless topology inverter, so meaning that when it comes to the connection, especially from the PV side, it's not allowed to ground either the positive or negative connection of the DC power. In terms of the efficiency, it's about 98%, IP class of 65, and we do have the Simo small class or power class of 3 to 8.2, and therefore we do also have other power classes in between there. This is also a 2 MPPT inverter, 3-phase like I mentioned, also transformerless. So all the Fronius Snap inverters are transformerless, and then the efficiency is 98%, and protection class of IP65. Then we also had the Simo hybrid that was the only hybrid inverter available at Fronius before the Gen24 Plus was introduced, and this was available in the power class 3.0, 4.0, and 5.0 with 1 MPPT and 1 battery connection, and the efficiency class of about 97.6%. The other category for the Snap inverters is with the commercial category, and this we have two variations or variants. We have the Simo inverter and the Echo inverter. For the Echo, we have the availability between the power class 10.0 up to 20 kilowatts, and then we also have the 12, 15, and 17.5 kilowatts in between. It means we have also, because of this abbreviation at the end, M, we have 2 MPPTs also in this inverter. And therefore, in terms of DC power connection, you can connect directly 6 strings into the inverter. In terms of input voltage, here we have 200 volts to a maximum of 1000 volts DC. And the efficiency is about 98.1. Ingress protection of 66. Then we do have the other inverter usable for commercial systems. That is the Echo inverter, 27 and 25 kilowatt power classes only, with 1 MPPT, as you can see with this abbreviation of the S at the end. So this means that this inverter has only 1 MPPT. And you can connect directly also here maximum of 6 strings to this 1 MPPT. And the biggest difference you can see also is with the input voltage. So the Echo has a narrower input voltage, so 580 volts DC to a maximum of 1000 volts, contrasted to the Simo that has 200 to a maximum of 1000. And the reason for this is because the Echo inverter is optimized for project business or for big installations, and therefore a part of the circuit that is referred to as booster circuit available for the Simos is not available for the Echo inverter. So here we have ingress protection of 66 as well. So just to give you now a better idea into the Simo advanced inverter. So It will be available in the power class 10.0, 12.5, 15, 17, and 20. So this, like we said, will have 2 MPPTs, and then the power class, in terms of the MPPTs, how much current you can connect to each of the MPPTs. We can see that you can connect anywhere from 27 to 33 amps for the first MPPT, and for the second MPPT from 16.5 to a maximum of 27 amps. In terms of oversizing, you can do 150%. And the most important feature with the Simo Advanced is the integration now of the arc detection, or the AFCI. So this is now integrated by default in this Simo Power Class 10 to 20. And this is now the differentiation between the older inverters and the newer inverters. So in terms of offering you the maximum safety, this AFCI does ensure that you are able to detect arcs before they develop into a fire. And this offers you precise detection of serial DC arcs. So this is purely on the DC side. And this is a trained algorithm based on many years of experience that Fronius has had with the perfect welding business unit, because as you know, for welding applications, you do have to deal with the possibility of arcing and how you eventually mitigate this kind of issues. So you can activate the AFCI feature through the user interface of the inverter. And all you need to do is to go, and you have to request, of course, the Profi menu. And with the Profi menu, then you scroll down to arc fault protection. And the arc fault protection, then you have to choose the AFCI mode. And then once you are there, you say AFPE mode on. So as simple as that, then you click on the enter button. This then allows you to activate the AFCI functionality for the Simo Advanced Inverter. So in terms of the concept of the Fronius snap inverters, so there is a reason why they are called snap inverters, because they come in two sort of components, so to speak. You have the inverter or the power stage component, and then you have the mounting bracket. But you can see here that you can also split the inverter into quite a number of other areas. So we have from position 1, which is the front cover. We have 2, which is the inverter component of it. We have 3, part of the mounting bracket, and 4 is the DC and AC connection area. And then we have part 5 that allows you to access connection for the data manager, for example. For there, you connect your data communication cables. And then you have part 6 that allows you to sort of protect the data communication area to the required IP class, whether 65 or 66. So this already covered, so I don't need to go back to it. So looking at some of the very specific features about the snap inverters, we have, for instance, this unique mounting bracket concept. So you can see that it has a hinge mechanism at the top, whereby once you have done the installation of the mounting bracket with the required number of screws per the recommendations from Fronius, and then you have done your AC and DC cabling at the connection area, then you're able to snap in the inverter into the mounting bracket. So this wall bracket is made from anodized aluminum. It can be used for wall mounting as well as pole mounting. No special tools are required. So here we only recommend the use of Tauros screwdrivers, especially for tightening the inverter screws. And then you have the integrated DC connection area, or the switchboard. And this allows you to connect your AC and DC power. And here you can use both aluminum and copper cables. So in terms of the cross section of the cables that can be used, you can go up to 16 millimeter square. So, and because you have no electronic parts here, then your fingers are protected. So there is no risk of an electronic or electric shock when you're working within the connection area of the wall bracket. The snap inverters also have a very unique service concept, meaning that you are able to identify any part of the inverter that has a fault or is damaged through state codes. Once this is determined, then you can do a board replacement, and then you can solve the problem on site without necessarily having to take the inverter from where it is installed to a workshop somewhere for maintenance. And therefore, this also means that because of this service concept, you do have very low maintenance costs. So this is an example of an exploded view of a snap inverter. So you can see that each of these sections can actually be ordered. So depending on which area or which particular spare part you do require, all you need is to check the right article number, and then you can order any of these parts directly from Fronius or through your sales partner. So Fronius inverters also, it doesn't matter whether the snap inverters or the Gen24 or even the Tauros will have active cooling. And this means we have, for the snap inverters, for instance, 2 to 3 speed controlled fans. So this air then is coming from the side of the inverter, and it's flowing over a heatsink that is located at the back of the inverter. And this heatsink then is cooling the electronics inside the inverter. Therefore, when you have more than one inverter for a project, the recommended mounting distance is at least 10 centimeters between the inverters. And this allows sufficient air to be taken through by the suction fan. And therefore, you do get also quite a bit of flexibility for mounting Fronius inverters. Because of this active cooling technology, Fronius does not give you a lot of limitations because, as you know, with passive cooled inverters, you have the possibility to mount them only in a vertical position, as shown here on the left. But with an actively cooled inverter like the Fronius snap inverters, you're able to mount them either vertically, you can do them at about 45 degrees incline, or let's say a variation from 90 all the way to a horizontal position, as you can see in these 3 illustrations. With active cooling, you are also generated or guaranteed a longer lifespan of the device, because as by a rule of thumb, the hotter an electronic part gets, the shorter the lifespan, and therefore the lifespan of an electronic device based on or depending on the operating temperature is given by this simple equation here, that the operating temperature or the optimum operating temperature plus 10 degrees Celsius, this in essence cuts the life of that electronic part by half. And therefore, by having active cooling, you stress the electrical and electronic parts less, and you are able to then guarantee that you have maximum life out of the device. So with passive cooling, what we can see is that you have a reduced lifetime of the inverters because you do get development of hotspots and potentially very high temperatures in the devices themselves. For snap inverters, we do have also, like we said in the introduction, the 2 MPPTs. And because of these 2 MPPTs, we talk about the superflex design capability of the Fronius snap inverters. So here we are talking about the Fronius Primo, the Simo small, and as well as the Simo advanced. We have the high yield potential, even in shaded conditions and different orientations. And you do have the wide DC input voltage from 150 to a maximum of 1000 volts. And in terms of the MPPTs, we said the Superflex and the multi-MPPT sort of concept for Fronius inverters is to have 2 MPPTs. And then in addition to this MPPT, we do have the dynamic peak manager. So this dynamic peak manager, in addition to what a normal MPPT is doing, is an additional shade mitigation or shade management solution from Fronius, and will allow you to maximize your yields from your DC side through the inverter. And this is happening by tracking or monitoring the IV curve of the All right, so let's now go on to the Fronius smart meter. And the Fronius smart meter offers you the possibility for data visualization and analysis of consumption data in SolarWeb. And therefore, this becomes a key for monitoring how efficient your energy flow is within your setup. So what is offered by Fronius as a smart meter is a bidirectional unit. So this means that it's able to measure and differentiate between consumption, that is how much power you're taking from the inverter and how much then you are taking from the grid side. In terms of availability, we have the Fronius Smart Meter TS. We do also have another version that did not have a touch screen. So in this case, the TS here means that it's a touch screen kind of smart meter. In terms of availability, we have three categories here. We have 100 amps, we have 65 amps. So these are more or less residential smart meters. And in terms of cable cross sections here, we can see for the single phase smart meter, 100 amps, we can connect up to 16 millimeter square. And for the three phase also, we can do a maximum of 16 millimeter square. For commercial systems, we have the 5 kilo amp three phase smart meter. So here we can do maximum 4 millimeter square. And therefore it means for current and voltage measurement, if this is required, then you would have to use CTs. So these are installed outside or external of the inverter. A quick look at the Fronius Ohmpilot. So the Ohmpilot is not an inverter per se, but is a gadget that is designed by Fronius to increase the self-consumption of your PV generated energy. And this is happening by stepless control of heat sources. So a typical application would be for hot water generation. And therefore here we would like to clarify that this Ohmpilot can only be used for ohmic consumers. So any load that is connected to the Ohmpilot should not have electronics in it. In terms of how much power you're able to control or deliver from the Ohmpilot, it can be anywhere from 0 to a maximum of 9 kilowatt. This can be done in both single phase steps of 3 kilowatts or three phase up to 9 kilowatts. It can be used for controlling 1 or 2 heating rods. So, and then you have easy communication, just very similar to the Fronius inverters, where you have WLAN, LAN, or Modbus RTU as communication paths for the Ohmpilot. In terms of the working principle, it's very simple how it looks like. So in a typical installation, you'd have your inverter generating power. For in this example, we have about 1,500 watts that is being generated. Typically, you'd have a load that is operating. As an example here, we have 1,000 watts, and then you could have these 500 watts being exported to the grid. All the inverter then has to reduce power export or power production to cover only what the load is consuming. But with the Fronius Ohmpilot, the inverter does not have to export this power or reduce the production. This then can be detected automatically by the Ohmpilot, and then this is directed to a heating element in a hot water tank for generating your hot water. So the only recommendation then would have to be to have a PT1000 temperature sensor connected to the Ohmpilot from the hot water tank for you to be able to monitor the temperature of the water inside the SolarWeb. For the requirements for the integration of the Ohmpilot, all you need is a Fronius inverter with a Data Manager 2.0. You do require a Fronius smart meter. That is a requirement if you want to integrate an Ohmpilot. Then you do require the Ohmpilot itself, and then the temperature sensor, which here we say it's optional, but you do require to monitor your temperature in SolarWeb. Please also include the PT1000 temperature sensor. Let's now have a look at the Fronius Gen24 Plus inverters. And here we also have some categories. So we start with the Fronius single phase Gen24 inverter, which we refer to here as the Primo Gen24 Plus. It's available in the power class 3, then 3.6, 4, 5, and 6. So it has a smaller housing compared, for instance, to the Simo, which is a 3-phase Gen24 Plus. It has 2 MPPTs and therefore similar features like the snap inverters as far as the dynamic peak management and the superflex design capability is concerned. And then these MPPTs can take either 22 amps for the first one or 12 amps for the second MPPT. And then there's an extra battery connection that has maximum current handling capacity of 22 amps. With this Gen24 Plus Primo inverter, you can get both PV point. So PV point is opportunity power without battery system, or full backup. So full backup, then you would require a battery to be connected to the inverter. The other category of the Gen24 Plus inverters is the smaller Simo category, that is 3 to 5 kilowatts, and the exact power classes are 3, 4, and 5. It also has a smaller housing compared to the bigger Simo inverters. 2 MPPTs as well, 12.5 amps for each MPPT, and 12.5 amps also for the battery connection, meaning that with this smaller Simo inverter, you are not able to get full backup out of it, but still you are able to get PV point functionality, just like with the Primo series. With the bigger Gen24 Plus inverters available in the power class 6, 8, and 10, we have a bigger housing. The MPPT's handling power is in terms of current, we have 25 amps for the first one and 12.5 amps for the second one. The battery connection maximum input is 22 amps. And therefore, because we have the right current here for the battery connection, it means that we can get both full backup as well as PV point, as well as backup options with the Gen24 Plus inverters. So the cooling concept of the Gen24 slightly different, although it's still actively cooled, but the positioning of the fan, as we can see here, is centrally placed on the front of the inverter. So the same attributes that we said for active cooling for the snap inverters still do apply for the Gen24. So, but the cooling concept here we can see is a lot more efficient because we have the dissipation of hot air from all sides of the Gen24 Plus inverter, and therefore this inverter is able to operate within wider ambient temperature ranges. So, but very quickly, the Gen24 Plus has other unique advantages, such as you can have storage of surplus energy, either through a battery system or integration of the Ohmpilot. But the Ohmpilot can also be something that can be integrated with a snap inverter without a battery system, just for your information. And therefore, with a battery system and storage of surplus energy, then you're able to increase your self-consumption rate. Then you can do recharging of the battery in emergency power mode. Then you can also do retrofitting. So if you have an existing snap inverter system that was done without a battery system, and now you want to retrofit a battery system, then you can do a Gen24 as a retrofit plus the battery system in an existing snap inverter kind of setup. Then you have the possibility for deep discharge protection, and then high output power, both for backup operation as well as straight conversion from the PV generator is available. So what you can see here is the concept that we refer to as multi-flow technology within the Fronius inverter. So you can have your DC power and AC power flowing in multiple directions at the same time. So at this point, let me hand over to my colleague Cyprian to take over and do the second part of the presentation. Cyprian?
Yes, indeed. Thanks a lot, David, for your wonderful presentation. So I will be taking over from this point to continue with the presentation. So I'm just trying to take control of the screen. So yes, so I want to believe that you can all see my screen now and hear me clearly. So we shall now be continuing from this point with the Fronius Wattpilot. Great, thanks a lot for the feedback, Mr. David. So yeah, so what's Fronius Wattpilot? It's basically Fronius's product that enables the use of surplus PV generated to charge EV in the most economical manner. So let's say you have, from this function overview, slide, let's say you have your PV being generated, being used for your base load. If you have any surplus, instead of feeding it into the grid and then eventually buy it back at a more expensive rate, why not use it to charge your EV? You know, so once you charge your EV, it of course increases your self-consumption, and of course also saves you a lot of money instead of buying back the grid that you fed in at a low rate at this time around at a higher rate. So that's basically what the Fronius Wattpilot helps you to achieve. So let's go into a bit more detail into the product. So we have two variants of the Fronius Wattpilot. The first one is the Wattpilot Go, as you can see. So with the word Go, basically just tells you that this sort of gives you a flexibility or mobility in terms of usage. And then we have the Wattpilot Home, which is more stationary per se, that can be installed in a more stationary fashion. But in both cases, you get the same level of productivity. So it comes with the same power classes of 11 kilowatts or 22 kilowatts. Next up is basically to tell you more about it. So with this, through the Fronius Solar Wattpilot app, you can actually gain full control of your charging regime, whether fully charged or just for the next trip, meaning that you can decide to charge it fully or basically just charge for the next trip. I'm going to tell you more about that in the subsequent slides. You can achieve cheap charging no matter if it's a day or night. And then you can now charge no matter where you are. That's with the application of the mobile version per se. That's with the Wattpilot Go. And then set and activate charging process from anywhere you are. Of course, this is achievable with or without a PV system, meaning that you can actually charge with a PV system. And then even without a PV system, you can also achieve economic charging of your EV from the grid. So to tell you more about this, we have different modes. So first up is the Eco mode. So this gives you the cheapest way to charge your EV. And what this basically does is that you have a smart system that once configured is able to track the tariff rates and then will eventually choose the best tariff, of course, the lowest tariff to charge with. So as you can see, in this case, we have different charging rates for different times of the day, as you can see in this case. So what this does is to smartly choose to charge your EV with the cheapest charging rates, as you can see. Although this for now is available in Germany and Austria, but I'm certain that as time goes on, it would be applicable in other regions and countries respectively. So next up is the next trip mode. This is actually a very interesting trip mode, mode to charge with. So what this basically does is to set the distance that you intend to cover for your next trip, say probably the next day. And then once this does, the Wattpilot charges the amount of kilowatts that would cover that distance. So this in a way helps to save you money. So instead of charging fully in a case where you don't have a PV, you're charging from the grid, it's going to charge just to cover the distance that you have programmed it to cover. So basically, if you're supposed to cover 60 kilometers tomorrow from 7 a.m., and then what this normally does is to now charge your EV to that specific kilowatt hour or the capacity that would deliver the distance that you're supposed to cover. Okay, so let's now go into another, because this is a Fronius products and solutions webinar. So basically giving you products, information about our products, and then solutions that we can use these products to provide. So next up here is the AC coupling solution. So basically the solution is all about the combination of a Fronius inverter and then an inverter charger to provide the most autonomous control mechanism. So this basically helps you to achieve the conversion, energy conversion that offers you the most efficient service, even during peak times, on peak times. Okay, so please keep your questions coming. We'll endeavor to answer all of them during the webinar. So, and of course, as this solution is concerned, it of course ensures maximum independence from fossil fuel powered diesel generations, as you will see in the subsequent slide. So what's it all about? In order to better understand it, we'll just have a quick look at DC coupling. So basically DC coupling it would be popular in most sub-Saharan African countries where the grid isn't stable. So we basically have the conventional connection from the PV to the charge controller to the battery and then to the inverter charger, in this case the Victron inverter, and then to the load. So we call this DC coupling because the interrelation between the PV and the inverter charger is basically at the battery point or at the DC point, one would say. So we can basically call this a DC coupled system. So now let's look at what an AC coupled system looks like. So this is basically it. So the charge controller is basically replaced by the PV inverter, in this case, the Fronius inverter. So the Fronius inverter actually comes with charge controllers that are already MPPT charge controllers that are already integrated into it. So it gives you the advantage of directly converting PV to AC. So you can now supply your load directly, and then the surplus generated can now be used to charge the battery, as you can see. So we want to also say that this can actually exist as a completely off-grid system, that is without the grid and the genset. Yeah, so this is actually possible. But then it is possible to, as an option, to have the grid integrated. So whenever the grid comes in, you can make use of the grid to complement what is being generated from the PV or vice versa. Same thing applied with the genset, of course. So just to give us the wholesome view, because this is AC coupling, and then we discussed DC coupling in the previous slide, it is also possible to have a combination of both AC and DC coupling. So this is basically how it looks like. So this is a wholesome solution, I would say, which gives us the opportunity to make use of the genset integrated into the microgrid setup, as you would say. And then the addition here is that we now have a charge controller with a portion of the DC of the PV generator, as you can see, still tied to the battery. So this is basically in a case where you're running a completely off-grid system without the opportunity of making use of the grid or the genset. You can actually have this setup to help you recover from a battery shutdown. In a scenario where there's no PV generation, probably at night or during an overcast, and then your battery has run down completely because of the fact that the inverter charger depends on the battery voltage as its reference voltage, you'll have a system shutdown. So in order to revive this system, you'll definitely need a charge controller connected to a portion of the already connected DC or PV generator to charge your battery to the needed threshold that would reactivate the inverter charger, and then you have your system back on running as your Victron inverter, in this case, generates the AC that serves as the reference signal or voltage for the Fronius inverter. So that's basically a combination of AC DC coupling with Fronius inverter. Of course, the GX component here can basically serve the purpose of to provide the internet connection to all the components, the Victron components in this system. You can also make use of Victron color control in this case to also function in an identical manner. Next up is basically to tell us how this the charging of the battery is achieved. It is actually achieved through what we call frequency controlled power reduction. When the state of charge of the battery approaches 100, the frequency on the output of the Victron, which is of course on the AC line, which is also where the Fronius inverter is connected, the frequency on that line increases. And then once that happens, it serves as a signal for the Fronius inverter to throttle down on the energy or the power generated from its end, and thereby enabling to ensure that the battery is efficiently charged. And then this, of course, elongates the lifetime of the battery. Going further is just to give us more information about off-grid applications in terms of interaction, inverter interaction. So we're not just compatible with Victron, we're also compatible with Tesla Powerworks, Electronics, Schneider, Studer, and other products, I would say. Yeah, so be it the single phase devices or inverters from the Primo through the Gen24 Plus and into the small Simo, and then of course, which are mostly implemented for residential solutions. It is also applicable for commercial inverters, the three-phase inverters, including the Simo, the Echoes, and of course also the Tauros inverters. Yes, so it's a good thing I mentioned Tauros last because because that's the next topic that we'll be discussing, the Fronius Tauros series. So the Fronius Tauros series includes the Fronius Tauros Echoes that comes in power classes of 50, 99, and 100 kilowatts with an MPPT voltage range from 580 to 930. These comes with a single MPP tracker. And then we now have the Fronius Tauros. This comes in a power class of 50 kilowatts with a wider MPPT voltage range of 400 to 870 with 3 MPPTs. Good. So one who might want to ask, okay, what makes the Tauros so special? It's actually easy to install. It provides rapid service. You can achieve AC daisy chaining. I'm going to explain that in the subsequent slide. You can achieve system monitoring hardware, which is on board, and then cost reduction due to flexible system design, which we'll of course also see in the subsequent slides. It is extremely robust and can be installed without any hassle and then any anxiety in terms of unprotected outdoors installations, because this inverter can actually be installed horizontally facing the sky, and then can be assured that there will be no ingress into the inverter. So taking a look at the topologies available, so we have the centralized topology and the decentralized topology. For the centralized topology basically implies the implementation of a system using DC combiner boxes, as you can see being described from this illustration. And then where it actually gets the name is that in most cases for this kind of installation, the inverters are usually installed in a centralized position. So as you can see, so we have the DC combiner boxes coming in with all the DC cables, longer rungs of DC cables to the centrally oriented inverters. Then we now have the decentralized topology, which is also called the direct topology, because you can now connect the modules directly to the inverters, as you can see, and then go with long runs of cable, AC cabling to the AC main distribution board or to the transformer, as the case may be. So just to point out the differences between the topologies, for the centralized version, we find that in this case, the inverters are usually close to the AC distribution board, and you normally have long runs of DC cable to the inverter, whilst for the decentralized or direct version topology, you have the inverter closer to the modules, and then it features longer runs of AC cabling to the AC main distribution board or the inverter. Next up is the orientation on the DC side. So if you're running a direct version, you're going to see MC4 plugs, which allows you to connect the modules directly to the inverter, as you can see. And then if you're running a centralized version or topology, because of the fact that from your DC combiner boxes, you'll be coming out with larger bigger DC dimension or diameter cables, where you would have your DC terminals in this orientation, so as to be able to accommodate your cables, and you can actually have it up to 95 mm squared. Yes, so that's for the DC. For the AC, it also presents a variety of options. You can actually go with single core cables or multi-core cables, as you can also see. And yeah, so it actually provides you a savings, a very special savings, because of the fact that it can actually help in reducing your capital, have a very great effect on the reduction of capital, OPEX, capital and OPEX, sorry, capital expenditure and operational expenditure, otherwise known as CAPEX and OPEX, which of course sums up to what is known as the TCO, or the total cost of ownership. And then how is this possible? So because the CAPEX actually consists of various components like the PV module cost, labor cost, balance of system, and CAPEX, and inverter, of course. So if you look closely, you have that the inverter actually costs about just 9% of the total CAPEX cost. But then the orientation or the feature of this inverter now helps to reduce the cost, the CAPEX cost, especially as it has to do with the balance of system. We're going to see that in the next slide. So having a look at the components of the balance of system costs, we can see that it ranges from the mounting frames, AC and DC cabling, especially cable trays and mains connection. So having a look at the AC and DC cabling, we can come in there to actually have a very, very good effect in terms of cost reduction. So this is possible because of the possibility of having AC daisy chaining. So I'm just going to give us a quick description of how this looks like. So it is now possible to AC daisy chain instead of having single runs from the inverter to the main distribution frame. It is now possible to daisy chain these inverters on the AC side, thereby reducing the cost of cabling by a whole lot. So just give us comparative examples. So we have one with an installation without AC combiner box, as you can see. So in this case, we have single runs of cabling from the Fronius Tauros, as you can see, to the AC distribution frame. Now compare it with the case where we have, so in this case, we have a total cable run of 150 meters, as you can see. So in a case whereby we're using the AC combiner box, as you can see, we're going to relatively limit the runs of cable we're going to have, because we're going to have 50, 50, and 3. So that's a total of 103 meters run. But then remember that you also have to include the cost of the AC combiner. And then now compare it to the situation where all you need to do is just AC daisy chain the Fronius inverters and then straight to the transformer or the AC main distribution frame. So it not only reduces the cost of cabling in total as compared to the other two references or examples, it will also reduce the cost of a separate AC combiner box. Good. So yes, just to note that a maximum of 200 kilowatts can be interconnected. So meaning that you can have 450 kilowatts interconnected, that is through AC daisy chaining, or 3 units of 100 kilowatts and 2 50s, or 2 units of 100 kilowatts of the Tauros. Good. Next up is the opportunity to integrate an AC disconnector. So this is basically how it looks like. So you have the opportunity of integrating an AC disconnector inside the AC output chamber of the inverter. So this is basically how it looks like. And of course, there's possibility of having a DC and AC SPD type 1+2. And yeah, so that's also possible. And you can see how they are oriented in this description. As it is for the Simo Advanced, arc fault detection is also possible. The AFCI is also integrated now in the Tauros. for maximum safety. So this is basically a safety regime that is dedicated on the DC side, which gives more interest or more concentration on the modules, especially as it has to do with arc faults. So we have this extra arc fault detection technology that helps to provide the maximum protection for your system, especially on the DC side. Good. Let's now talk about PV-Genset solution. So basically, this is simply the integration of PV into an already existing PV-Genset system, or it can actually be a greenfield installation. Greenfield meaning that a new installation. So this goes a long way in saving energy in terms of fuel expenses per se, and of course helps you to decouple from fossil fuel dependency, and of course reduce your carbon footprint. So how is this achieved? Like I said earlier in the previous slide, it's basically the integration of PV into an already existing or new installation of genset, so as to achieve a maximum blend of PV and fossil fuel consumption. Yeah, of course, by the use of a control mechanism. So this is basically how the system looks like, and I'm going to just quickly describe the components. So we have the Fronius inverter that converts the direct current coming from the PV generator into AC, which is now injected into the system. We have the system controller that serves as the brain of the system. So this system controller measures what is needed from the load side, and then once it does so, it now complements what the genset is providing with as much PV power as possible. We have the genset that serves as the primary source of energy for the system. Of course, we have the load point that is, of course, the primary object of the system. That is, it is an optimal mix of the fossil and solar energy is channeled towards providing efficient energy or power supply for the load point. And then not to forget the current sensors that that serves as the channel through which the system controller knows what the load point is demanding in terms of power. And then, of course, as an option, you can actually have the grid connected to it. Good. So for PV genset solutions, we can actually have it in low penetration or in a high penetration. In any case, it is essential to do a proper load profiling to be able to ascertain to what level you would want to, as an installer, implement the PV genset solution. But in any case, to summarize, the dynamic control of PV power is definitely necessary. So in order to achieve this, it is of course pertinent or very, very important to know what the minimum genset loading is. This is usually available from the genset manufacturers. Through your load profiling, you should be able to ascertain what the peak load demand is. And then with that, we'll now be able to ascertain what the inverter power is. And then from there, we can now determine from the over-dimensioning capacity of the inverter, know what level of PV power that can be installed on the DC side, that is with respect to the module capacity. So that's basically how we roll. So we provide you with the PV Genset Advanced and Professional, but then not forgetting the PV Genset Easy, which has been discontinued per se. That is with the Fronius PV system controller, but then we still offer support to all installations, to all such installations. So for the PV Genset Advanced and Professional, there's just a slight difference between them. For the PV Genset Advanced, this is basically a solution that basically entails the introduction or the implementation in a brownfield, that is an already existing system. And then for the professional solution, basically has this implementation in a greenfield solution, basically having most of the products from the same manufacturers per se, in terms of the gen sets and the control device. Good. This, of course, would help in boosting your ROI. So this is a reference that we always make use of, but then, of course, with constant monitoring. Yeah, so system whereby the total cost of the plant was about 216,000 euros. And then with an annual savings of 45,000 euros, within 4 to 8 years, the system was completely amortized. And then from the 5th year, to be specific, the savings rose up to 68,500 euros. And then, of course, we all know that the price of diesel hasn't been kind per se, always increasing. So as it is increasing, it also translates to an increase in the annual savings. And just to tell us how this system reacts in terms of operating time or reaction time, I would say. So it's a because that's a very important point to note. So as to prevent what we call negative feedback. So in terms of the system running on the PV-Genset regime, so you can have your consumption at this level, and then probably a heavy load is switched off. You can see that the reaction time is swift, so as to prevent a negative feedback in the system. Good. So next up is a conclusion to answer the question. Okay, why would you want to go for Fronius? Well, from all what you have seen so far from David and me, the answer is simple, because we come to you with at least 31 years of experience in the Fronius solar energy. It is a family-owned business which ensures financial and organizational stability. It comes to you with quality products that would last you a lifetime. We have a team of experienced and technical experts that will guarantee international support and, of course, rapid service. So, don't see any reason why you wouldn't want to go with Fronius, of course. So yeah, that's basically it. So that kind of brings me to the end of the presentation. Yeah, so for most of the topics that we have discussed so far, we have them detailed. We have dedicated webinars for them. So since this was basically a product and solutions webinar, we decided to just bring you a compendium of all our products and solutions. And you can actually find further information about them from our homepage, where we offer operation and installation instructions via this link. We can also find us on YouTube, our YouTube channel, where you can find how-to and installation videos, and of course, webinar recordings. And talking about webinar recordings, you can actually have access to all the webinars that we have presented in our Sub-Saharan Africa playlist via this link. So, for further information with regards to questions, technical questions, training, sales, and after sales, please don't hesitate to use any of these contact details. But then if you want to have access to or contact us, the TSAs, please do so with respect to the technical sales advisor responsible for your region. Myself, Cyprian Okolo, for the Western Africa region, Byron Kotzer for the Southern Africa region, and David Mwangi, who's with me in this webinar, for the Eastern Africa region. So that basically brings us to the end of the webinar today. Thank you very much for staying tuned and attending webinar. And until we come your way next time, do enjoy the rest of the day. Thank you.